powered by artificial intelligence.
Today's AI desk has one clean theme. Agents are moving out of demos and into real infrastructure. NVIDIA is calling the data center an AI factory. OpenAI is showing election safeguards and a self-improving tax workflow. Google is trying to keep source discovery and payments connected to AI experiences. Hugging Face is pushing local robots and faster model operations. The story is not one chatbot feature. It is the stack around the model getting serious. Power plants converted energy into electricity, while AI factories convert energy into tokens. NVIDIA says the economics are measured by tokens per second, tokens per watt, cost per token, utilization, and uptime. That framing matters because it treats AI as production infrastructure, not just software. The key NVIDIA point is that agentic AI changes the workload. Always-on inference is not just answering a prompt. Agents reason, plan, search, use tools, retrieve data, write code, take action, and sometimes create sub-agents. That makes workloads longer, deeper, and more compute-intensive. The infrastructure has to keep the entire workflow moving, not just generate a neat final paragraph. That is why NVIDIA keeps saying full stack. An AI factory is not only GPUs. It is accelerated compute, fast memory, storage for context, networking for coordination, software for orchestration, CPUs for execution, and the power and cooling to keep the whole machine useful. If one layer bottlenecks, the expensive accelerators sit idle. The race is becoming a systems race. OpenAI's May 27th election safeguards post is the trust layer story. OpenAI says its 2026 focus is to surface reliable voting and results information, support cyber infrastructure defenders, increase transparency around AI-generated content, combat misuse, and monitor political bias. That is a broad promise, but the important part is the operational detail: source routing, cyber tools, provenance, and enforcement. For election information, OpenAI says it will provide live vote counts from the Associated Press in the United States and Brazil beginning this fall. In the United States, it also says it will partner with DemocracyWorks to display reliable voting and registration logistics, including voting locations and election processes. That is exactly the kind of thing AI products need more of. Not confidence theater, but routing to authoritative sources. OpenAI also says it is investing in a multi-layer provenance approach. The post points to SynthID watermarks for images generated through ChatGPT, Codex, or the OpenAI API, continued support for C2PA metadata, and a public verification tool for checking whether an image was generated with OpenAI tools. The post is careful. Provenance is not a complete solution. But for election content, it is part of the basic safety infrastructure. The most practical agent story today is OpenAI and Thrive Holdings' post about self-improving tax agents with Codex. They describe tax AI for Crete accountants, built around practitioner expertise and production traces. The post says the pilot processed 7,000 tax returns across participating Crete firms. This is not a general assistant pretending to know tax law. It is a domain workflow with expert review and structured feedback. OpenAI's post says tax AI saves practitioners about a third of their time on tax preparation, drafts returns with up to 97% accuracy, and increases throughput by about 50%. Treat those as OpenAI and Thrive's reported pilot numbers, not universal tax automation laws. The bigger point is the loop. When a practitioner corrects the system, that correction can become structured evidence for the next improvement. This is the agent pattern we're stealing. The system captures the path from source files to extracted fields, citations, downstream submission, and expert correction. Then it groups recurring failures and turns actionable patterns into eval targets for Codex. That is how an agent moves from flashy demo to improving product. It needs evidence, tests, and domain experts close enough to tell it what actually matters. OpenAI also published a warp story around building open source with GPT 5.5. The useful way to read it is as another example of agentic development moving closer to real software work. The model is only one part. The product has to live inside the developer's workflow, understand the repo, propose edits, run tests, and keep the loop moving. That is why terminals, IDEs, and code review flows are becoming prime AI surfaces. Agentic development is not just autocomplete with better branding. It is a task loop. Understand the goal, inspect the code, make a scope change, run checks, explain the result, and wait for human review. When that loop is reliable, software teams get leverage. When it is loose, they get churn. So the important question for every coding agent announcement is simple. How much of the real engineering loop can it handle without making the reviewer clean up the mess? Google's search update is the source discovery story. Google says it is updating AI mode and AI overviews to help people find relevant websites, deep insights, and original content across the web. The post says AI responses will show suggestions for where to go next, including unique articles and in-depth analysis. In plain English, Google knows AI answers need stronger paths back to the web. This matters because AI answers can collapse a research journey into one generated summary. That is convenient, but it can also hide the original reporting, data, and expert context behind the answer. Google's update is an attempt to make AI search feel more like a starting point than a dead end. For creators, publishers, and researchers, that distinction is huge. Google Pay's developer update is where agents start touching money. Google says developers can power new agentic commerce experiences using the same Google Pay infrastructure and payment service provider relationships they already use. The post also announces a Google Pay and Wallet Developer MCP server. Translation: agents are being connected to checkout systems, developer tools, and payment rails. Once agents can shop or check out, the hard part is not making the button work. The hard part is control. Users need confirmation, merchants need reliable payment rails, and developers need boundaries around what an agent can do. Agentic commerce will not be judged only by convenience. It will be judged by whether people trust it when real money is involved. Hugging Face's Reachy Mini post brings the agent story into robotics. The blog says Reachy Mini can now run its conversation stack fully locally. The stack uses a cascaded voice pipeline, voice activity detection, speech-to-text, an LLM, and text-to-speech, exposed through a real-time API-compatible WebSocket. Hugging Face says local mode means no cloud, no API keys, and no data leaving your machine. Local robot conversation matters because robotics has different constraints than a web chatbot. Latency feels physical. Privacy is more sensitive, when microphones and cameras are in your room. Reliability matters because the device is embodied. Hugging Face's recommendation stack includes Llama.cpp with Gemma 4, Celero VAD, Parakeet TDT speech recognition, and Qwen 3 TTS, but the bigger idea is modular control. Hugging Face's Delta Weight Sync Post is a ModelOps story, and it is more important than it sounds. Hugging Face says a TRL pull request encodes only the changed weight elements as a sparse safetensors file, uploads that to a Hugging Face bucket, and has VLLM fetch it. On Qwen 3-0.6b, they say the per step payload drops from 1.2 gigabytes to between 20 and 35 megabytes. That matters because modern training and reinforcement learning workflows move enormous checkpoints around. If only a small part of the weights changes at a step, shipping the whole model is wasteful. Hugging Face also says it ran a disaggregated setup where trainer, VLLM, and a Wordle environment lived on separate machines or spaces, with weights flowing through a single hub bucket. That is the kind of plumbing that can make experimentation less painful. Put the day together and the message is clear. Agents need factories, receipts, and controls. NVIDIA is talking about the physical and software infrastructure. OpenAI is talking about elections, tax workflows, and coding loops. Google is talking about web source discovery and payment infrastructure. Hugging Face is talking about local robots and efficient weight movement. The AI race is becoming less about a single model demo and more about whether the surrounding system can carry real work. Here is what to watch next. First, cost per token and tokens per watt, because infrastructure economics decide what can scale. Second, production eval loops, because agents only become useful when mistakes turn into measurable improvements. Third, permissions around search, purchases, and civic information, because agents that act need boundaries. The winners will not just have smarter models. They will have better operating systems for AI work. That is today's desk. Less hype, more receipts. AI is becoming infrastructure, and the serious announcements are the ones that explain how models connect to sources, experts, payments, robots, tests, and compute. If you are building with AI, do not only ask what the model can say. Ask what the whole system can verify, improve, and safely do.